Massachusetts, it is not legal to use 14/3 Romex to convert hardwired smoke detectors in an existing dwelling to low-voltage smoke detectors. The National Electrical Code, which is adopted by the Massachusetts State Building Code, no longer permits the use of 14/3 Romex for low-voltage applications. National Electrical Code Article 725.152 states that Class 2 and Class 3 circuits shall not be run in the same cable, box, raceway, or enclosure with conductors of electric light or power circuits, except as permitted in 725.154 or 725.156. 14/3 Romex is a Type NM cable containing 3 conductors of 14 American wire gauge wire, one of which is bare for grounding. Class 2 and Class 3 low-voltage circuits require the use of separate conductors and cables designated for low-voltage applications. Alternative wiring methods that meet the requirements of National Electrical Code 725.152 for low-voltage applications include firstly, Class 2 or Class 3 cables such as CL2, CL3, CMP, and CMX. Secondly, isolated wire and cables such as thermostat wire. And thirdly, twisted pair cables such as Cat5 and Cat6. When dealing with electrical installations, it's always crucial to consult the most recent version of the National Electrical Code in any local amendments adopted by your jurisdiction. This ensures that all work is performed safely and in compliance with current regulations. Understanding the specifics of the NEC requirements for different types of circuits is essential for electrical safety and proper functioning of systems. Class 2 and Class 3 circuits are defined by their voltage and current limitations, which are designed to reduce the risk of electrical shock and fire hazards. These circuits are commonly used for applications such as control systems, signaling, and communication. The separation of Class 2 and Class 3 circuits from power circuits is a fundamental safety principle. Running them together in the same conduit or enclosure could lead to dangerous voltage induction or insulation breakdown, potentially causing equipment failure, fire, or electric shock. National Electrical Code Article 725 provides detailed guidelines for the installation of Class 2 and Class 3 circuits, including requirements for wiring methods, overcurrent protection, and grounding. These requirements are designed to minimize the risk of electrical hazards and ensure the reliable operation of low-voltage systems. When selecting wiring methods for Class 2 and Class 3 circuits, it is important to choose cables and conductors that are specifically listed and labeled for these applications. Class 2 and Class 3 cables are designed to meet specific performance requirements for voltage rating, insulation resistance, and flame propagation. Using the correct type of cable ensures that the circuit will operate safely and reliably over its intended lifespan. In addition to cable selection, proper installation practices are also crucial for the safe and effective operation of Class 2 and Class 3 circuits. This includes proper termination of conductors, secure mounting of cables and enclosures, and adherence to all applicable codes and standards. When working with low-voltage systems, it is important to remember that even though the voltage levels are lower than those of power circuits, there is still a risk of electrical shock. Always take appropriate precautions, such as energizing circuits before working on them and using insulated tools and equipment. In addition to the National Electrical Code, local codes and regulations may also apply to the installation of Class 2 and Class 3 circuits. It is important to consult with local authorities to ensure that all work is performed in compliance with applicable requirements. Proper planning and preparation are essential for any electrical installation project. This includes reviewing the applicable codes and standards, selecting the appropriate materials and equipment, and developing a detailed installation plan. By taking these steps, you can help to ensure that the project is completed safely, efficiently, and in compliance with all applicable requirements. Furthermore, consider the environment where the wiring will be installed. For example, if the wiring will be exposed to moisture or chemicals, it is important to select cables and conductors that are specifically designed for these conditions. In addition, if the wiring will be installed in a plenum space, it is important to use plenum-rated cables that meet specific fire safety requirements. Understanding the different types of cables and conductors available is essential for selecting the appropriate wiring method for a particular application. Some common types of cables and conductors used for Class 2 and Class 3 circuits include firstly, thermostat wire, which is a multi-conductor cable commonly used for connecting thermostats to heating and cooling systems. Secondly, security system cable, which is a multi-conductor cable commonly used for connecting security system components such as sensors and alarms. Thirdly, data communication cable, which is a twisted pair cable commonly used for data transmission in computer networks. Each type of cable has its own unique characteristics and performance capabilities. It is important to select the appropriate cable based on the specific requirements of the application. In addition to cable selection, proper termination of conductors is also crucial for the safe and effective operation of Class 2 and Class 3 circuits. Conductors should be properly stripped, terminated, and secured to prevent loose connections, which can cause overheating and electrical hazards. Various types of connectors and termination methods are available for Class 2 and Class 3 circuits, including firstly, wire connectors, which are used to join two or more conductors together. Secondly, terminal blocks, which are used to provide a convenient point for connecting and disconnecting conductors. Thirdly, insulation displacement connectors, which are used to terminate conductors without stripping the insulation. It is important to select the appropriate type of connector based on the size and type of conductor being used and the specific requirements of the application. When working with Class 2 and Class 3 circuits, it is also important to be aware of the potential for electromagnetic interference or EMI. EMI can disrupt the operation of sensitive electronic equipment and cause data corruption. To minimize the risk of EMI, it is important to use shielded cables and conductors and to follow proper grounding practices. Shielded cables have a metallic layer that surrounds the conductors and blocks electromagnetic radiation. Grounding helps to provide a low impedance path for unwanted electrical noise. In addition to these measures, it is also important to keep Class 2 and Class 3 circuits separated from sources of EMI, such as power lines and electrical equipment. The National Electrical Code provides specific guidelines for grounding Class 2 and Class 3 circuits. These guidelines are designed to minimize the risk of electrical shock and to ensure the proper operation of electronic equipment. Grounding should be performed in accordance with the NEC and any applicable local codes and regulations. Proper overcurrent protection is also essential for the safe and effective operation of Class 2 and Class 3 circuits. Overcurrent protection devices such as fuses and circuit breakers are designed to protect circuits from damage caused by excessive current flow. The National Electrical Code provides specific requirements for overcurrent protection of Class 2 and Class 3 circuits. These requirements are based on the voltage and current ratings of the circuits and the type of equipment being protected. Overcurrent protection devices should be selected and installed in accordance with the NEC and any applicable local codes and regulations. In addition to the technical aspects of Class 2 and Class 3 circuits, it is also important to consider the aesthetic aspects of the installation. Wiring should be neatly and professionally installed and should be concealed whenever possible. Cables and conductors should be properly supported and secured to prevent damage and to maintain a clean and organized appearance. The installation should be aesthetically pleasing and should not detract from the overall appearance of the building or structure. When performing electrical work, it is always important to prioritize safety. Electrical work can be dangerous, and it is important to take precautions to protect yourself and others from harm. Always to energize circuits before working on them and use insulated tools and equipment. Wear appropriate personal protective equipment such as gloves and safety glasses. Follow all applicable codes and standards, and never take shortcuts or compromise on safety. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and in compliance with all applicable codes and regulations. Hiring a qualified electrician can help to ensure that your electrical system is safe, reliable, and up to code. Finally, always remember to document your electrical work. Keep records of all materials used and any modifications made to the electrical system. This documentation can be helpful for future maintenance and troubleshooting and can also be required by local authorities. Proper documentation can help to ensure that your electrical system is safe, reliable, and well maintained. In summary, working with low-voltage circuits requires careful attention to detail and a thorough understanding of the applicable codes and standards. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and up to code. Remember to consult with a qualified electrician if you have any questions or concerns. When installing or modifying electrical systems, always refer to the latest edition of the National Electrical Code and any local amendments. Code requirements can change, and it is important to stay up to date on the latest regulations. Failure to comply with code requirements can result in fines, penalties, and potential safety hazards. Always prioritize safety when working with electricity, and never hesitate to seek professional assistance if needed. Furthermore, consider the long-term maintenance and reliability of the electrical system. Choose high-quality materials and equipment that are designed to last and perform well over time. Regularly inspect the electrical system for any signs of damage or wear, and address any issues promptly. Proper maintenance can help to extend the life of the electrical system and prevent costly repairs. When selecting electrical equipment, consider the energy efficiency of the products. Energy-efficient products can help to reduce energy consumption and lower utility bills. Look for products that are ENERGY STAR certified or have other energy-saving features. In addition to energy efficiency, also consider the environmental impact of electrical products. Choose products that are made from sustainable materials and are recyclable. Proper disposal of electrical waste is also important to minimize environmental pollution. Always dispose of electronic waste in accordance with local regulations. When planning an electrical installation, consider the future needs of the building or structure. Design the electrical system to accommodate future expansion or changes in use. This can help to avoid costly modifications in the future. In addition to these considerations, also be aware of the potential for electrical hazards such as arc flash. Arc flash is a dangerous electrical explosion that can cause serious injury or death. Take precautions to protect yourself from arc flash hazards, such as wearing appropriate personal protective equipment and following safe work practices. Arc flash hazards can be mitigated by using arc flash rated equipment and following proper safety procedures. Electrical safety is a shared responsibility. Everyone who works with electricity should be aware of the potential hazards and take precautions to protect themselves and others. Promote electrical safety in your workplace and community. Electrical safety training is essential for anyone who works with electricity. Provide regular training to employees on electrical safety hazards and safe work practices. Encourage employees to report any electrical hazards or concerns. By working together, we can create a safer environment for everyone. The principles of electrical safety and code compliance extend beyond just residential applications. Commercial and industrial electrical systems have their own unique set of requirements and considerations. These systems typically operate at higher voltages and currents and require more robust safety measures. In commercial and industrial settings, it is important to have a comprehensive electrical safety program in place. This program should include regular inspections, maintenance, and training. It should also address specific hazards such as arc flash, electrical shock, and equipment failure. Commercial and industrial electrical systems often involve complex control systems and automation. These systems require specialized knowledge and skills to install, maintain, and troubleshoot. It is important to hire qualified technicians who have experience working with these types of systems. Furthermore, commercial and industrial electrical systems are subject to more stringent regulations and codes. These regulations are designed to protect workers, the public, and the environment. It is important to stay up to date on the latest regulations and to comply with all applicable requirements. In addition to safety considerations, commercial and industrial electrical systems also have unique performance requirements. These systems must be able to reliably deliver power to critical equipment and processes. Any interruption in power can result in significant financial losses. Therefore, it is important to design and maintain these systems to ensure maximum reliability. Redundant power systems and backup generators are often used to provide uninterrupted power in critical applications. Regular testing and maintenance of these systems are essential to ensure that they will function properly in the event of a power outage. In summary, commercial and industrial electrical systems require a higher level of expertise and attention to detail than residential systems. Proper planning, installation, and maintenance are essential to ensure safety, reliability, and compliance with regulations. Always consult with qualified professionals when working with these types of systems. The principles of electrical safety and code compliance are constantly evolving. New technologies and materials are being developed all the time, and codes and regulations are updated to reflect these changes. It is important to stay informed about the latest developments in the electrical industry. Attend industry conferences, read trade publications, and participate in continuing education courses. By staying up to date on the latest information, you can ensure that you are providing the best possible service to your clients and customers. In addition, it is important to be aware of the ethical considerations involved in electrical work. Electrical contractors have a responsibility to protect the safety and well-being of their clients and the public. They should always act with integrity and honesty and should never compromise on safety. Ethical behavior is essential for maintaining the trust and confidence of clients and the public. In conclusion, electrical work is a challenging and rewarding profession. It requires a combination of technical knowledge, practical skills, and ethical behavior. By staying informed, following best practices, and prioritizing safety, you can have a successful and fulfilling career in the electrical industry.